Today in class we talked about double replacement reactions, and so what tonight's video is all about is how to predict the products of a double replacement reaction. And the way we predict the products of a double replacement reaction is essentially we are going to look at our solubility rules. Now this, you don't have to copy all these solubility rules down. They are going to be linked for you in Classroom. You'll have a document that you can look at. But we have classes of compounds, for example, given here, and you should pull this up while you're watching it so it makes sense. So we have classes of compounds that are going to be soluble, and these guys are always going to dissolve in solution, always going to be soluble. So basically these compounds are anybody who has an alkali metal in group 1A, the ammonium compound, as well as nitrates, chlorates, perchlorates, and acetates. So if you have those in you, you're going to be soluble. Also, we have some other things that are going to be soluble. It looks like the way the formatting came out on this one, we have like on this chloride right here, that is a 1- charge. Looks like it tried to make it a subscript instead. But if you have a chloride or bromide and iodine, you're going to be soluble as well. But there's an exception to the rule. The exception is if you have lead-2 in you, or silver, or the mercury ion. That makes you insoluble. Okay, so we're going to talk about that more. Sulfates are typically soluble. Sulfates are. But when you put strontium, barium, lead, calcium, mercury, and silver, it makes the sulfate insoluble. But when it's with everybody else, it's going to be soluble. Some of the insoluble compounds that do not dissolve, carbonates, phosphates, oxalates, chromates, and sulfides, they're insoluble, except when you put them with alkali metals and the ammonium ion. So the alkali metal presence causes it to be insoluble. So let's take a look at what we're talking about here and give you an example of this. So the example I gave you is aqueous solutions of sodium iodide and silver nitrate are mixed. So we're going to go ahead and write this. So we have sodium iodide to start off with. Now it does tell me here that the sodium iodide is an aqueous solution. So that means it's soluble. So we're going to put an AQ here. But it would also be soluble because of the rule here. And the rule is alkali metals are soluble. It has an alkali metal in it. So it's going to be soluble. Okay. It also has an iodide in it. And the iodide solubility is down here at the bottom. It has an iodide, which makes it soluble. It says except when it's with the lead ion, the silver ion, or the mercury ion. So it doesn't have those. So this is definitely going to be soluble. But like I said, the aqueous allows us to know it's soluble. We're going to put this guy together with silver nitrate. Silver has a 1+ charge. Nitrate has a 1- charge. And that's going to be aqueous. It tells us it's aqueous, but we can also apply our solubility rules to it. And there's a solubility rule down here telling us about nitrates and how nitrates are always soluble. Okay, now what we're going to do is we're going to predict what our products are. Okay, so this is a double replacement reaction. Sodium and silver are going to swap places. They're going to switch places. But when we write the new formula, we have to look up charges, crisscross those charges. So we're going to have the sodium ion. Remember, a sodium ion is 1+, and it's going to combine with the nitrate ion, which is a 1-. And so crisscrossing those charges, we get sodium nitrate. Now, to determine if this is soluble or not, again, we're going to apply the solubility rules. Remember, alkali metals are always soluble. Nitrates are always soluble, so this guy is going to definitely be soluble, aqueous. Then we're going to go on to the silver. So we're going to take our silver ion, which our silver ion is listed right here, or silver atom, rather. So that's going to be Ag. Silver always forms a 1+ charge. And then we're going to combine that with iodine. And iodine, group 7A, a halogen, is always going to form a 1- charge. So we're going to form silver iodide. Okay. Now what we have to do is look at our solubility rules to see whether this is going to be soluble or not. Okay, see if there's any rules that apply here. Now, the rule that does apply is we have an iodide. There's the rule. They say iodides are soluble except when they're with the lead or the silver or the mercury. So we do have it with this iodide with a silver. Iodide with a silver makes it insoluble. So this is going to be our solid formed. Okay, and we're balanced there. So that's how we can write out our our ionic equations, or excuse me, our double replacement reactions or metastasis reactions, and we can predict which of the products is going to be soluble or insoluble. Now, sometimes in tonight's homework practice I'm going to give you, we just might throw a compound at you and ask you, hey, is this soluble or insoluble? So let me give you an example of that. Okay, so we have 3 examples here, and we're going to look and try to determine, are they soluble or are they insoluble? Okay, and we're going to use our solubility rules. So our very first one is calcium carbonate, CaCO3. So I'm going to go up here and I want to look for a rule that deals with calcium or the carbonate. Okay, and I'm looking down here and I've got a rule right here that deals with the carbonates. Right there it says carbonates are insoluble. Okay, so we know it's insoluble except, let's see if there's an exception to the rule, and there is an exception to the rule, except with alkali metals and ammonia. Okay, so carbonates are insoluble except with alkali metals. So we have to ask ourselves, is calcium an alkali metal? And by looking at the periodic table, it's not. It's an alkaline earth metal, so that does not make this insoluble compound turn to soluble. So this is going to be insoluble. Okay, the next one we have is beryllium hydroxide. Beryllium is an alkaline earth metal, group 2A again. So we'll look up here for alkaline earth metals, and there's not really anything that deals with alkaline earth metals. Not really anything going on here. So we have to look at our hydroxides. And so right down here at the bottom, excuse me, we've got a bell going. Okay, so on our hydroxides, we have hydroxides are insoluble except with alkali metals. Okay, so an alkali metal would make a hydroxide soluble. And calcium, strontium, and barium, those guys are going to be soluble. So this is not calcium, strontium, and barium, so this is definitely going to be insoluble. Okay. And the next one we have is sodium oxalate. Again, sodium is an alkali metal in group 1A, and we have a rule that deals with that. It says alkali metals are always soluble. And so we can stop right there. This guy's going to be soluble. And so that's how we use the solubility rules to determine if something is soluble or insoluble. If it's soluble with no exceptions, it's always going to be soluble if it's present. If it's soluble, but there's exceptions that make it insoluble, we've got to look for that. And the other way it goes around as well. Sometimes we have insoluble compounds that have no exceptions, or insoluble compounds that can have exceptions to make it soluble with the presence of an alkali metal or ammonium. Okay, that's tonight's lecture, all about predicting the products of a chemical reaction and solubility.